This video provides easy-to-follow instructions for you to create this plastic box using Onshape. Click below in the video description. Here you will find links to all of the resources you need to complete this project. First, there is a link for a PDF instruction sheet. Click this link and open the project drawings and specifications in a new browser tab. Next, if you don't have an Onshape account, use one of these links to create a free account at the Onshape website. Last, there are links for each of the segments of this video. The video instruction is organized into 5 segments. In Segment 1, you will read the engineering drawings. Segment 2 will establish the design intent. In Segment 3, you will create the part model using Onshape. Next, you will check the accuracy of your model by checking its mass properties. Last, you will check the design intent by making changes to the model to see if it will update correctly. Now you are ready to begin the project. In this segment, we'll read the engineering drawing for this plastic box. Let's start by identifying the views provided in the drawings. First, there is an isometric view showing the plastic box as a 3-dimensional pictorial. Next, 3 orthographic views. On the bottom left, a front view. Projected above the front view is the top view. Projected to the right of the front view, a right section view. The cutting plane line in the front view show the cut location and the view direction of the section view. There is a detail view of the lap joint where the two halves of the box connect together. This detail is enlarged from the right section view. When planning a parametric model, we first need to identify its basic shapes and included features. The top, front, and right side orthographic views show the box has a rectangular shape with parallel sides. All of the outside edges are rounded with fillets. The dashed hidden lines in the front and top views, as well as the solid lines in the right side section view, show that the interior of the box is hollow. The detail view shows that the box is split on its horizontal midline and the top and bottom join with a lap joint. The section view shows the inside walls are angled inward, getting thicker toward the top and bottom. Next, we'll look at the dimensions and notes. First, the dimensions are in millimeters. The overall length is 150 millimeters. The width of the box is 100 millimeters. The height is 50 millimeters. All of the outside edges of the box are rounded with a 5 millimeters radius fillet. The note tells us that the wall thickness of the box is 2.5 millimeters, and the inside walls have a draft angle of 3 degrees. The detailed drawing shows an enlarged section of the lap joint where the top and bottom halves of the box join. This lap joint is 1.25 millimeters wide and 2.75 millimeters high. The mass units are measured in grams. The material is ABS plastic. Next, let's establish our design intent. To start, we need to identify any features that might be changed during the design process. The length of the box might need to be changed. Also, the width of the box might need to be adjusted. The height of the box might be increased. The height of the parting line that separates the top from the bottom might be adjusted to make the top portion smaller. Next, let's consider what features will not be changed in a revision. The wall thickness will remain at 2.5 millimeters. The draft angle of the inside walls will remain at 3 degrees. The outside fillet edges will remain at 5 millimeters radius. So how should the box respond when the parameters are changed? I should be able to change the height, and the width, and the length, and the box will update without errors. Also, I should be able to adjust the size of the lid to be smaller. It will again update without errors. Before we model the part in Onshape, let's preview the steps in the modeling process. First, from the drawing, we will identify the profile we will use for the base sketch. In this project, we will use the top view to create the base sketch. Sketch 1 will be placed on the top sketch plane, and the origin will be placed at the center of the rectangle. We can use Sketch 1 to extrude the height of the box. Next, Fillet 1 will round over all of the outside edges. Before we divide the box into 2 parts, we can create its interior cavity using shell. Then we can use Split to break it into a top and bottom. Sketch 2 will define the size and location of the lap joint. Sweep 1 will add material to the bottom edge for half of the lap joint. We can use a Boolean function to remove material from the top edge for the matching half of the lap joint. Draft 1 will add the angle to the walls on the bottom half of the box. Draft 2 will add the angle to the walls on the top half of the box. This results in 2 finished parts. So now let's get started in creating the plastic box. I have started a new Onshape document and named it Plastic Box. The workspace units are set to millimeters and the mass is set to grams. Let's start by setting the parameters we identified in the design intent as variables. Click on the button for the variable table on the right. There will be 3 variables. Length with a value of 150 millimeters, width with a value of 100 millimeters, and height with a value of 50 millimeters. This looks good. Close the variable table. Notice the variables have been added to the top of the feature list. Start a new sketch and choose the top sketch plane. Use N from the keyboard to view the sketch normal to the screen. Use P on the keyboard to turn off the visibility of the sketch planes. Click on the center point rectangle from the sketch toolbar. Click coincident to the origin for the center of the rectangle. Stretch it horizontal and click. Right-click and choose End Rectangle. Click on the Dimension tool and start by clicking on the length. For the dimension, use hashtag from the keyboard to open the variable list. Choose Length. Use Enter to set the dimension. Set the width the same way using the variable. This looks good. Use the green check to end. Next, we will use Extrude to add the height to the box. Click on the Extrude tool on the feature toolbar. This will be new. For the sketch region, click on Sketch 1. For the depth, enter hashtag from the keyboard. Choose Height from the list. Use Enter to set the value. Check the box for symmetric to center the box above and below the sketch plane. This looks correct. Use the green check to accept the feature. Next, we will round the outside corners using a fillet. It is important to round the outside corners before we use shell to hollow the inside. Shell will mirror the outside shape to create the inside recess, matching the fillets on the outside. Click on Fillet from the feature toolbar. Set the radius to 5 millimeters. We can use a window to select all of the outside edges. This looks right. Use the green check to close. To create the hollow space inside the box, we will use the hollow function of the shell feature. Click on Shell on the feature toolbar. Check the box for hollow. For the part to hollow, click on the box. Set the shell thickness to 2.5 millimeters. Use the green check to close. We can now use Split to create 2 separate parts for the top and the bottom. Click on Split from the feature toolbar. For the part to split, click on the box. For the entity to split with, click on the top sketch plane from the feature list. Make sure the boxes are checked to keep tools and keep both sides. Use the green check to close. You should see 2 parts now listed on the parts list. Now turn off the visibility of part 1. I can see this is the bottom, so right-click and rename bottom. Rename part 2 to top. Now turn off the visibility of the top. You can see the result of the shell feature here. Now turn off the visibility of the bottom and turn on the top. This looks good. We can now use a sketch to define the size and shape of the lap joint. Click in the parts list to turn off the visibility of the top view. From the camera and render view options, click on the option for section view. For the section plane, click on the right plane in the feature list. Use the green check to close the section dialog box. Now we will start a new sketch and choose the right sketch plane from the feature list. Use N from the keyboard to view normal to the sketch plane. Click on Use from the sketch menu and click on this inside corner of the section view. Now, use a corner rectangle to define half of the lap joint starting with this corner point and dragging up and to the right. For the width, enter 1.25 millimeters. For the height, enter 2.75 millimeters. This looks correct. Use the green check to close. Right-click and turn off section view. We can now use a sweep to add material to the bottom. This will create half of the lap joint using Sketch 2. Click on Sweep on the feature toolbar. This will be Add. For the sketch region, click on Sketch 2 from the feature list. For the sweep path, click on the inside top edge of the bottom half of the box. We will continue to follow this edge around the inside, adding to the profile all the way around this half of the box. This looks good. Use the green check to close. Now to complete the lap joint, we have to remove material from the top half of the box. We could use a sweep again to remove material, but it is easier to use a Boolean function. In the parts list, turn on the visibility of the top. From the camera and render view options, click on the option for section view. Again, use the right plane for the section plane. You can see the interference from the bottom shown as red in the top section. We can use this interference to subtract material from the top. Click on Boolean from the feature toolbar. Click on Subtract to remove material. For the cutting tool, click on the bottom from the parts list. For the target, click on the top from the parts list. Check the box to tool so that we keep both halves of the box. Use the green check to close. Click on the bottom on the part list. This looks correct. Now we can use Draft to add the angles to the inside walls. Click to turn off the visibility of the top. Click on Draft on the feature toolbar. Set the angle at 3 degrees. For the neutral plane, click on the narrow face on the top edge of this half of the box. For the entities to draft, click on the inside vertical walls on each side. The direction arrow should be pointing towards the inside, and the wall should be thicker at the bottom. Click on all of the interior walls. This looks right. Use the green check to close. Turn on the visibility of the top and turn off the bottom. Apply the same draft feature on the interior walls of the top. For the neutral surface, again click on the narrow face on the edge of this half of the box. For the entity, click again on each vertical wall. Again, make sure the arrow is pointing to the inside. Continue selecting the interior walls. Then use the green check to close. The 2 parts of the box are now complete. Let's take one more look at the section view to check the interior details. Click on Section. Click on Right View on the view cube. The lap joint and the draft angles all look correct. The project is complete. In this segment, we'll check the accuracy of the model by checking its mass properties. To check the model, the mass units should be set to grams and the material set to ABS plastic. If the size and shape of your model was completed accurately, the mass should be 146.523 grams. Let's look at this process step by step. First, open the document that contains the model of the plastic box. Next, check the workspace units. And make sure that mass was set to grams. Next, set the material to ABS. Go to the part in the parts list. Click on both parts to select them. Right-click and choose Assign Material. In this case, we're searching for ABS with a density of 0.001. Click to select it. Next, go down to the lower right corner and click on the Display Mass Properties button. When the dialog box opens, click on both parts, and the display shows a mass of 146.523 grams. If this was your result, then your part is accurate and matches the specifications. If not, we can troubleshoot to locate the sketch or feature that has an error. First, locate the rollback bar in the feature list. Move the rollback bar up to just below Extrude 1. Make sure that the part is selected to display its mass property. The mass now reads 789 grams. If you have an error here, examine Sketch 1 or Extrude 1. Now move the rollback bar down to below Fillet 1. The mass is now 782.403 grams. If you have an error here, examine Fillet 1. Now move the rollback bar down to below Shell 1. The mass is now 131.881 grams. If you have an error here, check Shell 1. Now move the rollback bar down to below Sweep 1. Make sure that both halves of the box are selected for the mass. The mass is now 133.616 grams. If you have an error here, examine Sketch 2 and Sweep 1. Next, move the rollback bar down to below Boolean 1. The mass is now 131.881 grams. If you have an error here, examine Sweep 1 and Boolean 1. Next, move the rollback bar down to below Draft 1. This adds material to form the angled inside walls of the bottom. The mass is now 140.105 grams. If you have an error here, examine the specifications used for Draft 1, including the edge selected for the neutral plane. Now, move the bar to the end. This adds material to form the angled inside walls of the top. Again, the mass should be 146.523 grams. If you have an error here, examine the specifications used for Draft 2, including the edge selected for the neutral plane. You should now have found any errors and your box is accurate to the specifications. In this segment, we will make some revisions to the box and check if our design intent has been applied correctly. We will start by reading the revision drawings to identify the features that will be changed. First, the length of the box has been increased to 200 millimeters. The width of the box has been changed to 125 millimeters. The height of the box has been increased to 75 millimeters. The parting line between the top and bottom sections of the box have changed to 60 millimeters above the bottom face. The other features, including the wall thickness, the draft angle, and the lap joint size, have remained unchanged. Notice, in the bottom section view, the wall thickness has increased as the 3-degree draft angle has been maintained. If the part updates correctly, the revised mass should now be 306.891 grams. Now we will make the revisions to the box. I have opened the Onshape document that contains the plastic box. Our design intent included changes to the size of the box, and these dimensions were set as variables in the Part Studio. Click on the button for the variable table on the right of the screen. From here, we can update the basic dimensions. First, change the length to 200 millimeters. Use Enter from the keyboard to update the model. Next, change the width to 125 millimeters. Again, use Enter from the keyboard to update the model. Last, the height is changed to 75 millimeters. I can see that the box has updated and there are no errors on the feature list. Now, we need to change the parting line. We use the top sketch plane when we split the box into the top and bottom parts. The location of the top plane was set in Extrude 1. Double-click on Extrude 1 to change the relative location of the top plane in the extrusion. First, uncheck Symmetric. Now the top plane is at the bottom of the extrusion. Check the box for the starting offset. We want the top plane to be offset 60 millimeters above the bottom of the extrusion. This looks right. Use the green check to close. Let's check in section view to see inside. From the camera and render options, click on the section view. Use the right plane for the section. I can see that the draft has changed, reflecting the new parting line, and the lap joint has been maintained between the top and bottom. So last, let's check the mass properties of the revised box. The mass is now 306.891 grams. If this is your revised mass, your box has updated correctly. Thank you for watching. If you enjoyed this video, look for more projects at cadvideotutor.com. Also, hit the like or subscribe button. If you have a question, leave a comment.